source in a particular internal NATed IP address. If there's HTML listening on that particular IP, it will respond with HTML and get loaded in the JavaScript interpreter, causing an error. If an error exists, you know there's a web server listening there. If it just times out, there will be no error, so you know there's not a web server there. And you just start cycling through as many IPs as you want. You can scan a whole class C using JavaScript, looking for web servers, vulnerable or not, in about a minute of time. So it's very easy to do port scanning, intranet port scanning. So again, a user goes to a rogue blog, a MySpace profile, and all of a sudden they're scanning your internal network and exploiting if they want. One more, we'll do two more little tricks here. We'll do some live demos later. If you want to tell where a user is logged in, there's different ways to do it. I'll show you just one. Let's say we're looking at that particular URL there, the mail.google.com. This is a particular URL that's static, and will give you two different types of content depending on whether or not you're logged in. If you're logged in, it'll show you your Gmail. If you're not logged in, it'll show you the login screen. You script source that in, and what happens is, depending on the state of the user, logged in or not, it'll cause the JavaScript interpreter to error on two different lines. If they're logged in, it'll error on line 8. If they're not logged in, it'll error on line 1. You just do some JavaScript checking, and you can actually see if they're logged in or not. If they're logged in, cross-site request forgery away, do things that they didn't intend to do. And you can do this on most any website out there. Different browsers are vulnerable to this, different versions. You just kind of got to play with it, but it's still very much alive and well out there. And for whatever reason, if they have JavaScript disabled, you can still do it without. You can still do internal port scanning without JavaScript because HTML has a way of pausing at different times. For instance, let's say a user went to a particular bad guy's website. They would give them these two tags right here. One is a style sheet reference tag pointing to an internal reference. And the other one is an image source pointing back to the bad guy with a timestamp on it when this page was delivered. What happens is when the browser renders these two particular links, if this 192 site is up, if it's up, it'll respond very quickly, just with HTML and not with cascading style sheets, but it'll respond very quickly, causing the next image source to respond really quickly. So if the timestamp is very close to when the next request came in, you know the server was up. But if for whatever reason that site is not up, the browser will hang for about 10 seconds, then time out and skip over it and then hit the image source. So you can actually do HTML timing-based attacks and do port scanning without the need for JavaScript. Now at this point, people are, a lot of times will say, well, is this stuff used in the wild? How prevalent is it? But and it's very hard to see, but we do know it has happened at least once with drive-by farming to do internet scanning. What the bad guys were doing was sending e-greeting cards to a bunch of users in Mexico. The users would click on these e-greeting cards, load up the page. JavaScript would then exploit the internal web interface to their DSL routers and update their DNS settings for several web banks. So the next time they went to the web banks, all the traffic went through the bad guys' sites. So all very easy to do, very simple to pull off, very hard to spot in the wild because it doesn't leave any traces or tracks. So this is what's going on out there. So we left this alone because the browser guys, as good as security guys want to be there, I mean, they're taking care of the syntactical attacks, but not the semantic ones. So I've kind of left that alone over the last year. And at Black Hat, I was starting to focus more on the semantic attacks of the business logic of websites, how to make a lot of money online, not using cross-site scripting, SQL injection, or any of the tricks. And other people out there, one at White Hat was doing more encoded types of attacks and how to code our current attacks like SQL injection and make them work again, even though people have taken measures to go against it. And Robert R. Hansen and also Tom Strassner have been looking more at exploiting Google gadgets and Web 2.0 type stuff. And they got to a certain point where there was an older type of attack that became useful. And this is where we get to clickjacking here. So I went back and I helped out Robert create some of this new clickjacking exploit code. So this is where we want to get to. Clickjacking, the new hotness. It's hard to get away from it in the press right now. Sorry about that. Didn't mean for it to get that way. So I'm going to tell you the story of how it happened for us from our perspective. But if you look at the Google Trends now, it seems clickjacking is on the same, is way more popular now than cross-site request forgery and just as popular as cross-site scripting, which is crazy to me. And now if you just do a search for clickjacking in Google, there's over 700,000 references to it, which is kind of insane considering that we just started talking about it about a month ago. So what is this clickjacking stuff, and why are we here? You know, for those that have laptops with webcams, you will care. Think of any button on any website, something that's particularly sensitive. This could be the wire transfer button on a bank, a PayPal button, a Twitter follow me button, your Netflix queue, a banner, any particular button online that you want to be clicking yourself and you don't want to be tricked into clicking. We're going to clickjack those. Now consider for a moment that JavaScript can now iframe in and take this button and hover it just under the mouse over any content on the web page where the user can't see it. So what clickjacking does is enable other types of attacks. And the more we research this, the more powerful the attacks got. You know, the sky was the limit, and when we saw the potential, it got a little scary. So just to visualize how this works, you have a page that the bad guy controls, or maybe they just control a piece of the content on it, a banner advertisement. They load in some JavaScript, and they iframe in a piece of code. Let's say the friend approval on MySpace. They iframe in this particular button, position the button exactly where they want it, and change the opacity so you can't see it, and it follows the mouse. Next time you click somewhere on the screen, you're actually clicking approve or follow or whatever the button tends to be. So again, just consider for a moment all the buttons that a bad guy might want you to press. The bad guy doesn't control the act of you clicking down the mouse, but they certainly control what it is that you click on. So we're going to start with some very simple examples to see how this works. So I'm going to drop out of this here and move you over to my browser here so you can see how this sets up. And we'll go through several demos here. So for instance, how a bad guy might want to use this. So for instance, let's say you want to monetize a little bit with Google advertising. You can have a page that you set up, and all it does is follow the mouse. You want somebody to click on your ads? No problem. You just follow the mouse around. You know, Google will say, or all the advertisers will say, "Oh, we have click fraud under control." I don't think so. The bad guys have known about this type of thing for a long while. So again, anywhere they click, they would click on the ad. If you want to make a story popular, if you have a particular blog post and you want to, just force a user to click on it, they will click on it. And again, I'm going to show you the code here real quick to somebody so you can see how simple this stuff actually is. Let's see here. So again, this is all of the code it takes, just some JavaScript to follow the mouse. If you guys want this code, let me know. It's really not all that difficult to put together, and my JavaScript skills are not great. So if we want to change the opacity, you just, let's see here. Actually, this probably won't work. I'll show you the opacity later because we're actually referencing it remotely, and I don't want to screw it up. So we have all that you can click. Let's say you can clickjack in YouTube rating systems, Netflix queues, all sorts of things. So it's quite interesting what you can do with this stuff. So we started messing around with this stuff. So let's go click through a couple of demos here. We did the dig one. So just to give you an idea of all the different buttons out there, there's, again, the dig stuff, the internal router buttons on your D-Links. There's, let's see, look at a few more here. If you use WebEx, you can get control over the user's desktop. There's social networking ones. But just think about all these buttons that a user might want you to click on. And there's lots of different proof of concept codes that people have put out there. And I'll give references to a couple. Sir Darkit, Thornmaker, and Gareth Hayes have done a lot of work with this stuff. Also, PDP has done quite a bit. Now, we were developing this stuff, so we can present it at some point forward. So we're keeping this, to ourselves and things that we were developing. And the other side effect that clickjacking has is that it bypasses cross-site request forgery token-based protection. For those that are not familiar with cross-site request forgery, you take a sensitive request, let's say a wire transfer link, or to your bank, and you put it in an image source or some tag, and you force the user to make a request they didn't intend to make. This again could be a wire transfer, hack the White House website, or anything you want really, and force the user to make this request. Now the way developers will defend against this attack is that they will put token-based protection. they will make a little token on the end of the URL that's tied to that user's session. So no request is the same for each user. They token-based protect it. The problem with clickjacking is it's the real user clicking on the real button on the real web page. So the token-based CSRF protection is null and void. So we started researching this and sharing our results around. But for years, we actually found out way later that this type of issue has been known, registered on Bugzilla, the Mozilla project, this exact attack. But it was, from our understanding, it was misunderstood, underestimated, and long forgotten. We got to this point and said, this stuff is kind of compelling. We could do some cool stuff with this, but certainly not enough for a good presentation and or a white paper. So we started to go a bit beyond. What else can we do with this stuff? Now, let me take a moment here. How many people here have, let's say, a computer with a webcam built in? Raise your hand, please. How many? A few? Okay, cool. Keep your hands up. How many people with a microphone? Okay, the rest of you don't have laptops? Okay. Now, on the internet, there's a nice little thing out there. It's on the internet, almost nobody knows that you're a dog. This is certainly true now. Now, we have web pages that when you visit them, they can tell where you've surfed, they can tell where you're logged into, perhaps your gender, they can scan your internet, what you can connect to. What if, just what if, a web page could see and hear you? What would that enable? That could enable corporate espionage, government surveillance, spying on home users. Practically speaking, every computer with a webcam or a microphone will become a remote monitoring device, something that you wouldn't see or expect. The problem is we're pretty good with JavaScript, for just doing these minor things. But JavaScript, to the best of our knowledge, doesn't have access to the webcam or microphone. So in our line of work, if JavaScript can't do it, you ask Daddy Flash. Flash has tremendous penetration. This is their latest statistics. In the latest version of Flash, the Flash player, and at the end, the 90115, in mature markets, they call it, has over 80% penetration. Flash Player 9, the one just before, has just over 97%. Huge penetration. And the great part about Flash is it does have access to the the camera and microphone. So let me show you how this works. Let's see here, where we got. Where we are. Okay. Now, we created a little Swift file, and I'm going to show you the code here. I can't see it, so I'm going to make this screen a little smaller here so I can see it. All right, this is what we call CamJack2. All this is a simple web page that's calling in a Swift file. And draw your attention here to this W mode equals transparent here. This is very important to pull off, but it's just calling in one Swift file here. And when the Swift file loads, it asks you for permissions to access the camera and microphone. Obviously, you want to give permissions before somebody accesses your camera and microphone, I would imagine. All right, so we had this particular thing here, so that was pretty interesting. Now, what we wanted to do next is we wanted to iframe this in so we can get it to follow the mouse. Okay, so what we did was we have this CamJack HTML thing here, and this is right here. Again, mouse follower code up above, iframes in the code, the CamJack2 HTML. So the first thing we're going to do here is, so you can actually see this in action here, is we're going to position this iframe here up to the top left. Okay? Very important that we do this. So we don't need that anymore, so we're going to focus here. So again, we're going to follow the mouse just a little bit here, okay? Now, we don't want it to be that big. We want it to be a little bit smaller. Actually, let's leave that a second. Now, the problem is, you can see this, right? The user can see this. We didn't like that. So we did this really clever hack here. It's called Moz opacity. And we found out that you can just do that. depending on the browser that you're in.